Hi, Kara here, author of the Serafina Loves Science series. I'm dropping in today to talk to you guys about quantum entanglement, which just so happens to be one of my favorite scientific concepts, but it's also one of the key scientific concepts in the second book of the Serafina Loves Science series, Quantum Quagmire. In Quantum Quagmire, Serafina's best friend, Tori Copper, is going through one of the most difficult things a person could ever experience, and that's the divorce of her parents. Serafina tries to help her best friend using the tool that she loves the most, science. As any good scientist, Serafina uses a lot of trial and a lot of error to help resolve this issue for Tori. Heavy emphasis on the error. Now, in the end, Serafina discovers there's a particular concept in physics called quantum entanglement that helps Tori make it through her parents' divorce. I'm not going to ruin it for you though. You have to read the book to better understand how Serafina uses quantum entanglement to help her best friend, but I do want to talk to you guys a little bit more in depth about the actual concept itself. So to understand quantum entanglement, we must first understand the word quantum. Now, quantum means very, very small. And when I say very small, I don't mean a small order of French fries, sea monkey small, pinky small. When I'm talking about small in physics, I mean the most basic building blocks of our universe, atoms, or things that exist at the atomic level. Now, even smaller than atoms are the particles that comprise or that make up the atom. The protons, the neutrons, and the electrons. For our purposes in quantum entanglement, I'm just going to focus on the electrons. Electrons orbit on the outside of the atom, kind of the same way that the planets orbit or rotate around the sun. Don't you think that's pretty interesting? How similar planetary orbit and electron orbit is? Back to the topic at hand. When electrons orbit around an atom, they get into particular patterns, which physicists call the spin-up, spin-down pattern. And that is just like it sounds. When one electron is at the top of its orbit, called spin-up, another electron will exist or be at the bottom of the orbit, which is the spin-down. And they continue to operate like this because they are in this spin-up, spin-down pattern. This is their configuration. This is the way that they're working best. Kind of like a team. If you play soccer, if you play football, if you play basketball, everybody has their own position. The same thing for electrons. Spin up, spin down. Then they switch. They get into these rotations. And it continues like this, okay? If they were to move out of their orbit, what would happen to the atom? It wouldn't be good. Anyway, as we know, because atoms are the most basic building block of the universe, they can make up a lot of different things. Elements, isotopes, compounds, and they all come together to form our most favorite things in the universe. Hot dogs, tacos, googly eyeballs. Can you tell that I'm hungry? Thinking about tacos a lot lately. Anyway, so if an atom is broken up because, let's say, it's forming a new compound or a new structure, and the electrons are broken apart, but the electrons maintain the spin pattern that they were originally in, no matter what, even if they're moved to opposite sides of the universe. It's kind of like they're connected by some sort of memory or a tie. It's kind of weird. Kind of strange. Einstein actually called this spooky action at a distance. So in other words, when electrons get into a spin up and spin down pattern, and they're broken up and moved to opposite sides of the universe, they continue to maintain that same pattern, just as if they were never separated. Think about that for a second. Electrons forever stay entangled. If that's true for the most basic building blocks of our world, what do you think that means for you and for your life? How do you think Serafina used this to help her best friend Tori make it through her parents' divorce? Quantum entanglement. Pretty interesting. If you like this video, please like, comment, and most importantly, share. I'm trying to get the word out there about Serafina and empowering kiddos in science, especially little girls. My name's Kara, and I love science.